Hi, Santa. Hey, so it looks like what your teacher is wanting you to understand the difference between rational and irrational. So, see over here where it's giving you a list of perfect squares. So, 1 times 1 equals 1. Therefore, the square root of 1, it's just asking what number, this symbol right here, square root, is saying what number divided by itself equals that. So notice 2 times 2 is equal to 4. So the square root of 4, 2 times 2 is equal to 4. So 2 is a perfect square root of 4. So any integer, not a fraction, these are part of what we call, fractions are rational numbers too, but these are called rational numbers. But then all of a sudden we have what's called non-perfect squares. So for example, what number times what number is equal to 3? Well, the only roots that 3 have is, or factors is 1 times 3. So the square root of 3 doesn't really apply. That means it doesn't simplify. And when a square root does not simplify, that's called irrational. So this is not a politically correct thing to say, but think about it. These are crazy numbers. It's hard to work with, right? So, for example, the square root of 25, well, 5 times 5, right? But the square root of 26, that doesn't simplify. So square root of 26 is irrational. But since the square root of 25 simplifies, that's a rational number. Now, this gets more complex later, so let's see what we have here. So, yep, the square root of 16 is equal to 4. So the square root of 16 is rational. But 23 is prime. It does not have two factors, so this is irrational. Now, they did a little trick here. Well, this is what I'm going to do. We're going to do this part first. We're going to leave the 5 down here. Well, the square root of 25 is 5. 5 divided 5 is 1. 1 is a rational number. So I think the aim is, here's square root of 18. Now this one's a little bit more tricky. So what I'm going to do is have you think about what are factors of 18 besides 1 times 18? There's 2 times 9, 3 times 6. 9 is a perfect square. So I'm going to have you rewrite the square root of 18 as 9 times 2. And that's the same as square root of 9 times the square root of 2. Well, look at the square root of 9 is 3. So this square root of 9 can be rewritten as 3. And now the square root of 18 is the same thing as 3 times the square root of 2. So let me do that again. The square root of 18 can be rewritten as, that right there is a perfect square, 9 times 2. You can rewrite that. You don't have to do this, but sometimes visually it makes it easier. Well, the square root of 9 is 3 times the square root of 2. So the square root of 18, and now look at, there's a radical involved, so this is still an irrational number. So you could practice with a bunch of these. So you could say square root of 100 is 10, so that's rational. But the square root of 99, well, I mean, there's 9 times, those aren't the same. There's 3 times 33, those aren't the same. So the square root of 9, now we could rewrite it as square root of 9 times the square root of 11, and the square root of 9 is 3. But because there's a radical involved as the final answer, this is an irrational number. And your teacher, later on, this is going to get more complex because you might have, say, the square root of 24 divided by the square root of 2. Well, here's one thing we can do. The square root of 24 we can rewrite as the square root of 2 times the square root of 12 over the square root of 2. Root 2 divide root 2, that's just the same, similar. 2 divided by 2 is 1. Any number divided by itself except for 0 will just cancel to 1. And now we have square root of 12. Well, the square root of 12 can be rewritten as root 4 times root 3, and the square root of 4 is 2. So this is what you're eventually going to be doing. But anyway, so hopefully this helps.